So the last section in chapter 2, when I look at the 5-number summary and outliers, we're also going to look at what you can do with the 5-number summary to put together a box and whisker plot. So here's the 5-number summary. In the 5-number summary, the 5 values that describe the 4 quarters of the distribution, meaning these are going to be the values that split up our quarters, 25, 25, 25%, all the way going across to see where are all of our points? How far apart is the lower 25%? How far apart is the middle 50% from each other? Okay? So you're going to be able to see different things. So those values, we have the min, the lower quartile, which is also quarter 1, median, which is quarter 2, upper quartile, which is quarter 3, and the maximum value. They're the 5 values that we use to put together a box and whisker plot. Now, one data set I'm going to have us look at is, we're going to use the data set to put together the box and whisker plot. And those 5 values are the 5 values that should be labeled when you put together a box and whisker plot, or they're the 5 values that we're going to use to describe what's happening. So here we have sparrow lengths. Okay, and we had a sample of sparrows. We looked at which ones died, which ones survived, and the length of the sparrows. Okay, so here's box and whisker plots on top of each other. And it's nice to see. You can see where the medians are, where the centers. You can see the consistency, which one's more consistent or not. And you can see the box whisker plot. The longer the whisker is, okay, the farther apart that 25% is from each other. Now the downfall of a box and whisker plot is, yes, we see the minimum. Yes, we see the quarter 1. We know where it starts and begins, but we don't know what's happening in between. This might be just one point far out there. Same thing with between each one of the points. We're not exactly sure what's going on in between. So we're going to make some general statements. Okay? If I ask you to describe a box and whisker plot, 2 things you have to describe are your spread and your center. Okay? So some different things you can say here, and people might describe them a little differently. Okay? The sparrows that survived have a larger variation. We can see that. Okay? The ones that survived, max and mins, excuse me, are farther away from each other. Okay, the ones that died are a little more consistent. I'm not going to say greatly consistent, but a little more consistent. The first quartile of the sparrows that died is greater than the third quartile of the sparrows that survived. This is describing the center. I know it's not talking about the medians. It's talking about the first quartile of the ones that died, the third quartile of the ones that survived. And that's actually a little more detailed. Right? If you're saying, okay, I know the median of the ones that survived is less than the ones that died, that's fine. But now, see, even going farther and saying the quartiles, quartile 1 for the ones that died is larger than quartile 3 for the ones that survived. 75% here, because we have 3 sections. We have the whisker and both sections of the box. 75% of the ones that survived are going to be shorter in length than 75% of the ones who died. So it's going a little more detail talking about the center. But when you talk about the center, I would like you to talk about one of the 3 quartiles, quartile 1, 2, or 3, and compare them with the quartiles of the other group when I'm asking you to compare box and whisker plots. Now these 2, number 1's comparing a spread, number 2 is comparing the centers from each other. Those are must. Those are 2 things you have to compare when you're looking at box and whisker plots. If you see something else interesting and you want to make one more general comment, you're more than welcome to do that. I did that here. The maximum lengths are about the same for both sets. And there are, we're not done measuring out, but I think they are exactly the same for the maximum values. So that means for no matter if they died or survived, the longest lengths are going to be about the same. Okay? So here's looking at box and whisker plots. Now, like I said before, from the minimum value to our first quartile, we don't know what's going on in between there. Okay? This might be just one point very, very far away. And the same thing might be true here. Okay? We might just have one outlier that's very, very far away. And that's why we have this whisker so big for the ones that survive, the upper 25%. Okay? If there's one point very far away, there's a chance it might be an outlier. So what we're going to look at now are modified box plots. Modified box plots are going to be box plots that have the outliers pointed out. So the whisker won't go all the way to the outlier. It'll be slightly shorter, and it'll be asterisks or some symbol to show that there are outliers there. So modified box plots identifies the outliers, marks with special icons. Whiskers only extend to the extreme non-outlier. So it stops. The whiskers on stop, and then you'll have some kind of symbol to show me that there's outliers. Now, how do we know a value is an outlier or not? There is a calculation. You're not just eyeballing it or by feel. Okay, this one looks a little farther away. Okay. Any score falling 1.5 times the inner quartile range less than the lower quartile and greater than the upper quartile. This really is kind of saying a whole lot right here. We are going to calculate the inner quartile range, multiply it by 1.5 times that amount, and you take it away from the lower quartile, you add it to the upper quartile, and that's going to be your range of points that are not considered outliers. Okay, so you're going to have a lower end and an upper end, and that's going to be your range for the outliers. Okay. Here's our data set for the sparrows that died. Okay, so it has our 5-number summary up there: the min, quartile 1, median, quartile 3, and the max. Okay, and right here is going to be the steps that we're going to go through. Okay, inner quartile range, doing some multiplying, and then adding or subtracting here. Okay, so the first thing I want to do is inner quartile range. Remember, inner quartile range was Q3 minus Q1. So in this case here, we're going to have 163.5 minus 161. Quarter 1 and quarter 3 are just up there, and that should give us 2.5. So there's our IQR inner quartile range. Inner quartile range times the 1.5. So 1.5, let's put it up here, 1.5 times 2.5, and that's going to give us 3.75. So that's going to be the value that we're going to take away from the first quartile. We're going to add it to the third quartile, and that's going to give us our range. So here's our first quartile, 161, minus the 3.75, and if we do that up, that should be 157.25. So there's our lower range. Anything below that, any sparrow that has a length lower than 157.25 would be considered an outlier. Now to add 163.5, there's our Q3, adding the 3.75, okay, and that should give us 167.25. So there's our range for those sparrows that died and the sparrow for the sparrows that died. So our range would be 157.25 to 167.25. Okay? So if we're looking at this, we can see, I mean, right now I don't have the whole data set, but we can see, okay, the minimum value is 156. That would fall below our 157, so we would have at least one outlier. We would know that would be considered an outlier because it's less, it's outside of our range. Okay? Over here, our max is 166. Well, that would be inside our range. Our max here is 167.25 for the normal range. That 166 would fall inside there. So there would be no maximum outlier, but we would have a minimum outlier. At least one, depending on how many other points would fall under 157. But we know at least one because our minimum value is 156. Okay? So for this section, be able to identify the 5-number summary, describe box and whisker plots, comparing them on top of each other, and also be able to calculate outliers, okay, using the rule of 1.5 times the inner quartile range. Okay? That should be it for chapter 2 then.